Good morning, 7th grade. Today we're going to be talking about estimating decimals. Last week we talked about rounding decimals, and I think maybe we did a couple examples of estimation, but then we went back to rounding. So we're going to talk more about estimating today. We may have done some of these examples, but it's okay if we do them again. As we go through this information, please fill in your notes. If you do not have the outline with you, you can either just watch it now and fill it in later, or you can print it out from Google Classroom. Alright, so estimating decimals. The purpose of estimating is to make the problem easier so you have a general idea of the answer. We use estimation when we need to get an idea of what the answer is, but we don't need the exact answer. And it can allow us to get the answer in our heads. When we estimate, we want to be able to figure out the answer in our head. The easiest way to estimate is to round each number to the highest place value. And that's what we'll do in example 4. We'll round each number to the highest place value. Before we do that though, sometimes if you pay attention, you might hear someone say, "Give me a ballpark figure." A ballpark figure is just another name for an estimate. So the next set of blanks is ballpark figure. It's an estimated answer. And you can see the yellow here. It comes from a baseball park. So here's Philly Stadium in Philadelphia. If we look at the outside of the stadium, right here, everything in here is part of the stadium. If a baseball player hits a baseball inside the stadium or inside the ballpark, we would know where to look for it. We would look inside the ballpark. Might have to look a little bit to find it, but we could find it. However, if someone hits the ball out of the park, oops, that didn't work. If they hit it out of the park, we don't really know where to look because it might have hit a car and gotten driven away. Someone might have picked it up and walked off with it. It might have fallen into a gutter or a ditch. We don't really know where to look for it. But as long as it's inside the ballpark, we know where to look. Just with same with numbers. If we give an estimate that's in the ballpark, it means it's close to the exact answer that we're looking for. Alright, so back to example 4. Part A says 456 and 39 hundredths minus 213 and 94 hundredths, and we need to estimate this. So we said the easiest way to estimate is to round each number to the highest place value. And what we learned in rounding last week is if we want to round to a particular place, we have to figure out what that is. What is the highest place in 456 and 39 hundredths? It's the hundreds place. So we're going to round to that 4. In order to round to it, we look at the next digit. The next digit is a 5. And if the next digit is 5 or greater, that means we round the number up. So this number, 456 and 39 hundredths, is closest to 500. The second number, also the highest place, is the hundreds place. So we're going to look round to that hundreds place. We look at the 1 next to it. Because that's smaller than 5, we round this, we keep it rounded down to the 2, so it's 200. 500 minus 200, you probably can do that in your head, is 300. So the answer for part A is 300. In part B, the highest place for the first number is the tens place. So 34 and 779 thousandths. If we're rounding to the tens place, we're going to look at the ones place. That 4 tells us that we are closer to 30 than we are to 40 because 4 is smaller than 5. So it'll be 30 times 20 and 24 hundredths. The highest place here is also the tens place. And the next digit is a 0, so that means we're going to stay at 20. 30 times 20. 30 times 20 is 600. If you didn't know how to do that in your head, I can explain a little trick to you. You might have learned this, but if you have numbers with a whole bunch of zeros at the end and you're multiplying them, you take the parts that are not 0, so the 3 and the 2 in this case, and you multiply them. 3 times 2 is 6. And then you count how many zeros are in the problem. We have 1 0 and 2 zeros, and you put that many zeros in your answer. So you end up with 600 as the final answer. Sometimes, if you want a better estimate, you can round to the nearest whole number. This will give you a better estimate because they're closer to the actual numbers. And if you remember from last week, round to the nearest whole number means round to the ones place. So in example 5, we're going to estimate by rounding to the nearest whole number. So part A is 14 and 629 thousandths plus 29 and 94 hundredths. If we round to the nearest whole number, we want to round to the ones place. In the first number, that's the 4. So look at the digit after it, the 6, which tells us that this number will be closer to 15 than it is to 14. So we have 15 plus. In the second number, the first 9 is in the ones place, and we look at the next digit, which is also a 9. So that tells us that this is closer to 30 than it is to 29. And 15 plus 30 is 45. In part B, if we round the first number to the ones place, or the nearest whole number, it will round to 77. And the second number rounds to 7. 77 divided by 7 is 11. So that's our estimate. I want to point something out. In this problem, it would not have worked to round to the highest place, because if we rounded these to the highest place, it would be 80 divided by 7, which is a weird decimal number. So we would not want to do that, and that's where rounding to the nearest whole number makes this problem a lot easier. But sometimes there are still problems where it won't work, or it will be easier to do something other than rounding to the highest place or to the nearest whole number. And so sometimes we need to use something called compatible numbers. Compatible numbers are numbers that work well together. Numbers that work well together. Compatible means two things go well together, and in math, compatible numbers are numbers that work well together. And we'll see that pretty clearly with this first part of example 6. How we would use compatible numbers in example 6 part A. When you have a division problem, I recommend, for the most part, that you round the second number first. So if we round this one to the highest place, we're going to say that it's 80, because the tens are the highest place, and the next digit is a 4. So we're going to do something divided by 80. We need to figure out what that something is. So we look at what we have. We have an 8, and then we look at what we have in the first number. 8 does not fit into 3, And it doesn't fit into 35, but there is a number very close to 35 that works well with 8. Can you think of what it is? Good. Some of you might have thought of 40. 40 does work well with 8, and I'll show you what that would look like, but there's actually a closer one. 32 is closer. So this could round to 320. You will notice that 320 does not follow the rules of rounding in any way. We're going from 35 all the way down to 320, or 35 all the way down to 32. It doesn't follow the rules of rounding, but it does use compatible numbers. Now we can do our division. When we multiply numbers that have lots of zeros, we work with the non-zero parts. It's the same thing with dividing. So we're going to take 32 divided by 8 is 4. And then we have 1 0 and 1 0, and this time instead of adding the zeros, we're going to subtract. So 1 0 minus 1 0 is no zeros in the answer. So the answer is just 4. Now I told you in this one we could have rounded to 40, and if we did that, that would follow rules of rounding because we're rounding to the highest place, and it would be 400 divided by 80, which will work. This is a little tricky though, because when we divide, we're going to do 40 divided by 8, which gives us 5. And then there's still only 1 0 minus 1 0. So the answer is just 5 because we don't have any zeros left. What happens is people look and say, ooh, there are 2 zeros here, and 2 zeros minus 1 0 means that I'll have 1 in my answer, but that's not correct. The reason that we don't have a 0 in the answer is because when we did 40 divided by 8, we already used this first 0 for the division, so we can't use it when we're doing the subtraction part here. Either way, whether we round to 320 or we round to 400, we get an answer that will be close to the real one, either 4 or 5. Both of those are very close. Both of those are good estimates. All right, on to part B. In part B, we could round to the highest place, and we would get 20 plus 80, and that works pretty well. You get 100. What I want you to become familiar with doing is when you look at problems like this, especially ones that deal with money, is look for combinations like 25 plus 75, because 25 plus 75 is also 100. Either of these, this method or this method, they would both work to get you the answer for an estimate. That also leads me to remind you that when estimation is supposed to be easy so that you can do it in your head. However, when I am grading your work to help understand what your thought process is, I will ask you to show your work. What I mean by that is I want you to tell me, what did you round to? So did you round to 25 and 75 and get 100? Or did you round to 20 and 80 and get 100? Did you round to 480 to get 5? Or did you round to 320 and 80 to get 4? Because with estimation, there's not one right answer. There are lots of answers that could be considered correct. And I'm concerned with knowing that you have followed estimation correctly and didn't just take a wild guess at the answer. All right, we have a couple more examples that we'll work through together. Example 6, part C. And for these, you can choose which way that you want to estimate. In part C, you might find it easy to round to the highest place. So it would be 10 minus 3, which is 7. Or you might say, you know what, this is small enough. I can round to the nearest whole number. 15 minus 3 is 12. you'll notice that these two numbers are kind of far apart. Which one do you think is closer to the actual answer? That's right, this one would be closer because 15 is a lot closer to 14 than 10 is. But I would accept both of those as correct answers. What I don't recommend is keeping decimals in your problem. I would not recommend doing 14 and 9/10 minus 3 and 2/10. Maybe you can do it, you get 11 and 7/10. But that one is not really quite so easy. And remember that the purpose of estimation is to make the problem easier. Alright, part D. Multiplication is often one where rounding to the highest place is the best, especially when you've got a number like this. So 5 and 5/10 times 184 and 332 thousandths. Let's start by rounding this to the ones place. We get 6 times this one. We could round it to 184, but that's not one that's easy to do in your head. So let's change and round it to the highest place, which would be the hundreds place. Because this is an 8, we're going to round it up to 200. 6 times 200. We've got lots of zeros, so we're going to do 6 times 2 is 12. And then there's 2 zeros in the problem, so we need 2 zeros in the answer. So 1200 is the answer. Part E. This is a division problem. And if you remember, I said in division problems it's often best to round the second number first. So if we round that to 8, we are looking for a number that is close to 92 that works well with 8. That might be a little hard for you to think of. So if when you look at your problem like this, you say, I'm not sure what to go with, then maybe you can look at this number first and say, you know what? That would round to 90. And I know what 90 divided by 9 is, and 9 is very close to 8. So that would be an okay estimate. 90 divided by 9 is 10. That one I think you would find to be pretty easy to do in your head. But let's go back to 8, just in case you wanted to look at that. There are two numbers that I would say would be good to use for this. You could say 96, if you know that one. 96 divided by 8 is 12. You could also go down to 88. Because 96 is about 3 away, maybe 4, not quite, a little more than 3 away. 88 is a little bit more than 4 away. Both of them are very close. And you probably know 88 divided by 8, that's 11. Do you notice how we got 3 different answers, but all of them are okay? I would accept all of them as long as you show what you rounded to. One other thing that you could do is you could round to 90, and you could choose to round 8 and 4/10 to the tens place. That's very close to 10. So 90 divided by 10 is 9. Now that gives us a fourth answer, and I would say that that would be an acceptable answer. This is why I ask you to show me what you rounded to, because there are so many different answers that you can get, and I want to make sure that you get credit for doing good work. Alright, finally part F. In this one we have 3 numbers being added together. So either look for a number that all of them are close to. These are not all close to the same number. Or look for some compatible numbers. Right here and right here, we've got 2 compatible numbers. This one, the first one, could round to 25, and the second one could round to 75. And we know that 25 plus 75 is 100, And that frees us up to be a little bit more specific with the one in the middle. If we round it to 116, then we've got 100 plus 116, which is 216. You might also say, hey, I want to round that middle number too. So 25 plus 100 plus 75 equals 200. That would be okay. Or you might say, I can round these all to the highest place. 20 plus 100 plus 70 equals 190. All of those answers would be okay as long as you showed me what you rounded to. That brings us to the end of our worksheet. If you need to, go back and watch this video again if you still have questions. After you feel like you understand what you're doing, then you can work on the homework. Oh, I realized I forgot. There are two more examples I do want to do that are not in your worksheet. So you can follow along with these. You can write them down if you want, or you can just follow along. So the first example, Isaac is having a party. He is inviting 10 friends. He estimates that each friend will eat 2.25 cups of punch. Well, that doesn't sound right. It should drink. Each friend will drink 2.25 cups of punch. Since 2 and 25/100 rounds to 2, he decides to make 20 cups of punch. Is that a good estimate? What do you think? Isaac followed the rules of rounding, but in this case, he would want to go against the rules of rounding because he would not want to run out of punch. In this case, his estimate will be lower than what he will need. So he would want to round up to 3 or possibly 2.5. So 3 times 10 is 30 cups of punch. This is what he would want to round to so that he doesn't run out of punch before everyone gets their drink. In the next situation, Eli is going shopping. He has $300 to spend. He sees a pair of shoes that cost $121.43 and a set of suitcases that cost $196.99. Since $121.43 rounds to 100 and $196.99 rounds to 200, Eli thinks he has enough money to buy both of them. Is he correct? Well, he is correct if he's following the rules of rounding. 121 does round to 100, and 196.99 does round to 200. So it seems like he has enough money. However, when you're working with money, you typically want to round down. If you're talking about how much do I have, you want to assume you have less than you need. Or when you're working with the cost of items, you want to round up to assume they're more expensive. So this one, we would definitely want to round 196.99 up to 200. But we would probably want to change this 123.43. Instead of going down to 100, we would want to round up to 125 or 130. And that means Eli would need about $325, so he would not have enough. When you are working with real-life situations, you need to use common sense. Sometimes common sense will tell you to go against the rules of rounding, and you need to pay attention to that. All right, now here's the homework. These are the problems that you need to complete for homework. They are due the next day that we have class. There is a bonus question. You must give a clear explanation for your answer in order to get credit for it. All of these problems are rounding or estimation problems. Remember, when you are estimating, show what you rounded to. Don't just write down an answer.